Something hit Uranus hard. Billions of years ago, something massive, and we mean massive, slammed into this planet so violently that it knocked the entire world sideways, and it never fully recovered. Right now, Uranus is rolling through space, tilted almost completely on its side. Its poles face the sun for decades at a time. Its magnetic field is broken and off-center. Its heat is trapped deep inside like a wound that never healed. Scientists still do not fully understand what happened, and by the end of this video, you will understand something most people never stop to think about. That one single collision billions of years ago may still be controlling everything about this planet today. Stay with me, because this story gets stranger the deeper we go. Let us rewind. 4.5 billion years ago, the solar system was not the calm, organized neighborhood you learned about in school. It was chaos. Giant clouds of gas and dust were collapsing and swirling. Rocks were smashing into rocks. Worlds were being born, destroyed, and rebuilt. And out in the cold outer region of this young solar system, far from the warmth of the newborn sun, something was quietly growing. Piece by piece, rock by rock, ice by ice, a planetary core was accumulating. Water ice, ammonia, methane, all frozen solid out there in the dark. These were the building blocks of what would eventually become Uranus. And the outer solar system had something the inner rocky planets did not: more raw material, more variety, more to work with. So this growing world got big, really big, more than 14 times the mass of Earth. It pulled in hydrogen and helium from the surrounding disk of gas. It was becoming a giant planet. But here's where the story takes its first strange turn. Uranus never became Jupiter. It stopped. Something interrupted the growth. Maybe the gas disk ran out too early. Maybe the core formed just a little too late. Maybe the conditions were too cold and too spread out for the final push. We do not know exactly why, but we know the result. Uranus ended up in a strange middle ground, too massive to be a rocky planet, not massive enough to be a gas giant. It became something we now call an ice giant, a category of planet that turns out to be incredibly common across the galaxy, and yet one we barely understand, partly because we've only ever gotten one close look at Uranus. One. That's it. Voyager 2 flew past in 1986 and kept going. Everything we know about this planet comes from that single encounter and distant observations from Earth, which means almost everything about Uranus is still wrapped in uncertainty. And the strangest part, the uncertainty is not just about details, it's about the most fundamental features of the planet: its interior, its heat, its magnetic field, its tilt. All of it still raises more questions than answers. Here is where Uranus starts to feel genuinely unsettling. Most planets in the solar system spin upright or close to it. Earth is tilted about 23 degrees, which gives us our seasons. Saturn is tilted about 27 degrees. Even Mars is tilted a similar amount. But Uranus is tilted 98 degrees. That means it is not spinning normally. It is rolling sideways. Its north pole points almost directly at the sun during one part of its orbit. Then, 42 years later, its south pole does. One hemisphere bakes in continuous sunlight for decades, while the other side sits in complete darkness. This is not a quirk. This is a full planetary identity crisis. And for a long time, astronomers assumed there had to be a simple explanation. Something must have hit it. One big collision, tilt the planet, story over. But the more scientists looked at Uranus, the more they realized the tilt was just the beginning of the weirdness, because Uranus is also leaking almost no heat. Every other giant planet in the solar system radiates more energy than it receives from the sun. Jupiter does it, Saturn does it, Neptune does it. They are all still releasing the primordial heat left over from their formation billions of years ago. Uranus is not, or at least barely. It looks thermally shut down, almost cold, and that makes no sense for a planet this size. A planet with 14 Earth masses should be radiating heat into space like a slowly cooling ember. The energy should still be there. So where is it? There are two possibilities scientists keep returning to. Either something is trapping the heat inside and it cannot escape efficiently, or a catastrophic event rearranged the interior in a way that fundamentally changed how heat moves through the planet. And that's when the impact hypothesis stops being just about the tilt and starts explaining something much deeper. Then there's the magnetic field. If you want to understand how bizarre Uranus really is, the magnetic field tells you everything. Earth has a magnetic field that's roughly aligned with its rotation axis and centered in the planet. Jupiter has something similar, just far more powerful. Uranus has a magnetic field that is tilted 60 degrees away from its rotation axis, and it doesn't even come from the center of the planet. It's offset, as if the dynamo generating the field is not sitting where it should be, not doing what it should be doing, not shaped the way physics says it ought to be shaped. The implication is that deep inside Uranus, something is very wrong. The interior is not arranged the way normal giant planet models predict. There may be strange layers of compressed water and ammonia and other materials in exotic states under crushing pressure. These layers might block heat. They might confine the dynamo to an unusual shell. They might be the reason the whole planet feels thermally and magnetically broken. And here's what makes your stomach drop a little. Scientists believe a lot of this goes back to that impact. The same event that tilted the planet may have also reorganized its interior, deposited heat in the wrong places, created stratification that trapped everything, produced a planet that looks almost normal from far away, calm, quiet, blue-green, and serene, but is carrying a hidden wound that has never healed in 4.5 billion years.
Now here is the moment the whole story has been building toward. What actually happened to Uranus? The leading theory goes like this. During the late stages of planetary formation, the outer solar system was still crowded with large objects, planetary embryos, protoplanets, bodies that never finished assembling into full worlds. And one of them, something potentially the size of 1 or 2 Earths, hit Uranus. Not a glancing blow, a deep, devastating collision under exactly the wrong geometry. The kind that does not just scrape the surface, but penetrates and scrambles the interior. The impact was so violent that it tilted the entire planet's spin axis from whatever it was before to nearly sideways. The energy was so enormous that it fundamentally altered how the interior was organized. Heat that should have been escaping for billions of years got locked inside behind new composition gradients, behind layers that refused to convect properly, behind a structure the collision helped create and that has remained essentially frozen ever since. And then, here is the part people almost never think about: the moons. Uranus has 5 major moons: Miranda, Ariel, Umbriel, Titania, and Oberon, and all of them orbit in the planet's equatorial plane, which means they orbit sideways too. Because Uranus is tilted 98 degrees, its moons go around it in a path that is almost perpendicular to the rest of the solar system. They are all aligned with the tilt, which means one of two things. Either those moons formed after the impact, born from the debris disk the collision created, in which case they are literally children of the catastrophe, or they existed before the impact and were slowly dragged into alignment over billions of years as the tilted planet reshaped the gravitational environment around it. Either way, the moons are carrying the memory of that impact in their orbits right now. Look at Miranda, the innermost major moon. Its surface looks shattered. Enormous cliffs, fractured terrain, strange mismatched regions that look like they belong on different worlds stitched together. Scientists used to think Miranda might have been broken apart by a collision and then imperfectly reassembled by gravity. It is not confirmed, but it fits the overall picture of a Uranian system that has been through something severe. Even the rings tell the story. Uranus has rings, but they are nothing like Saturn's bright, sweeping bands. They are dark, narrow, almost skeletal, like remnants of something that started bigger and got ground down over time. So here is what we are actually looking at when we look at Uranus. a planet that formed in the cold outer solar system, built itself up to giant scale, never quite became a gas giant, then got hit by something enormous, got tilted sideways, got its interior reorganized, got its heat trapped, got its magnetic field twisted into an off-center, off-axis mess, and then spent the next 4.5 billion years quietly rolling around the sun, looking almost peaceful from a distance, while internally carrying the consequences of one ancient catastrophic moment it never recovered from. The event probably lasted a few hours. The consequences have lasted longer than complex life has existed on Earth. That's what makes Uranus so haunting. It is not a dead planet. It is not a simple one. It is a giant world still living in the posture of the blow that changed it. And the next time you see that small pale blue-green dot in a photograph of the outer solar system rolling sideways through the dark, you will know it is not just spinning. It is still falling from that impact. It just never hit the ground.